So we are going to learn about complex types of data. So we already learned many things about the tabular data. Now, this chapter is discussing about complex types of data. What are complex types of data? We can see some multi-dimensional analysis and how we can do the descriptive mining of complex data objects. And we will learn just a little bit about mining spatial database and also mining multimedia database. When we are dealing with the complex data objects, we need to understand the generalization of structured data. So we have the complex data object. What is the complex data object? Maybe you understand the data object is a kind of table, and one row means one object. Another row is another object. But we can have a complex data object. The first generalization of structured data we can see from the set value attribute. In this case, we want to see the generalization of its value in the set into its corresponding higher level concepts. So, for example, we have hobby. The hobby can be tennis, hockey, or playing chess, or violin, or playing Nintendo games. If we want to make it more specific, you can have like this one. It is very specific: tennis, hockey, chess. But this kind of hobby, it can be the category of sports. So we call this is a set value of an attribute sport. So sport is the generalization. So we want to make it more general. Or we can have the derivation of the general behavior set, such as the number of elements in the set, the types or value ranges in the set, or the weighted average for numerical data. So we can also have, we call this is the generalization. Or if we want to make the opposite, if we want to make this opposite, we call this is the derivation. So we want to make the lower concept, or we want to make the lower element of the higher concept. It can be the categorical data, it can be numerical data. We can also have another kind of generalization of structured data using list value or a sequence value attribute. It is the same as set value attribute, except that the order of the elements in the sequence should be observed in the generalization. For example, I have the human activity. So my research is in the human activity. Let's say this activity contains of boiled water, put noodle, put sauce, and then serve noodle. So I know that this is a sequence. then I can say that this is a higher activity as a cook ramen. So this is a sequence of activity that can be resembling cooking ramen. So this is the list value or a sequence value because you will do this one as a sequence. So when we are dealing with the spatial and multimedia data, there can be another kind of data. For example, the spatial data. Spatial data means we want to generalize the detailed geographic points into cluster. The cluster regions can be like business area or residential area or industrial area or agricultural area according to the land uses. So in this case, yeah, we can merge a set of geographical areas by the spatial operation. So if you know, in Korea, they have some area that has been determined. Let's say, yeah, this is the metropolitan area. Okay. So I think in Korea, they specific mention that this area is about the industry in IT and then materials and etc. But in Jeju, it is specific area for tourism and health. So yeah, they can make that kind of spatial based on the industry, or you can also deal with the other kind of areas like business and residential and etc. This is about the spatial data. If we want to make the generalization of image data, so the image data, it can be extracted by aggregation and or approximation. For example, we can see from the size, we can see from the color, shape, texture, orientation, and the relative position and structures of the content objects or regions in the image. So in image data, there are many kind of things we can deal with. For example, I want to see this orange. Whether this orange, we can pick this orange or not. If it is already red, okay, this is yellow. Then nowadays there are some robots. So the robot can pick this orange because the color is already yellow. The texture is already okay. But this orange is not okay. So we need to wait because the color is still green. So this kind of things we can do with the image data. Or you can deal with the music data. If you are dealing with, if you know music, okay, we can summarize its melody. It is based on the approximate patterns that repeatedly occur in the segment. So some melody, we can understand whether it is a pop song or a ballad song or jazz and etc. And we can also summarize the style based on the tone or the tempo or the major musical instrument. So you can distinguish, for example, whether it is piano or trumpet or guitar or drum. So we can distinguish the sound. So those kind of things, we can also deal with the data and we can do the data mining. So whenever we do with the complex data types, we also need to understand the data warehouse. So the data warehouse is, we learned about the data warehouse before. The spatial data can be also stored in the data warehouse. If you remember, the data warehouse have some properties. The data should be integrated, so it should integrate many other columns or other tables. Should be subject oriented. So if it is customer related data, then it should be related with the customer information, or should be related with the supplier information. It should be related with the location and etc. Time variant. You already remember. We can deal with the long time horizon. Maybe if the time horizon is 5 years, this is the long period for the data warehouse. If it is only 1 year or 6 months until 1 year, that is the operational data. We can also have the non-volatile spatial data repository for the data analysis and decision making. So all those properties are the properties in the data warehouse that is fit for the spatial data. And we can also deal with the spatial data integration. So it is a big issue. So if you are later dealing with this kind of data, maybe you need to understand the structure. What is the structure of the spatial data? We have the raster versus vector. So raster is like this one. You can make like grid. So grid means the box. So if you have like this box, so you want to make it as grid. You want to make grid, and then for every box you can make color. This one is green, this one is blue. So you can distinguish that, okay, I know that the blue color represent river. This green color, it represent land. So the green color is the land, the blue color is the river. If you use the line features, maybe the line features is like this one. So usually the raster line, it is more clear because we can understand it from the grid or for every cell like this one. Or if you are studying the object oriented, OO. So in the programming, we have the object oriented, OO. If you are making an object, then you can define the object, you can define the attribute, like what I mentioned before. If we have the table, so one row means one object, so you can have a lot of attributes. So we can make it as the object oriented, or you can make as the relational models. So the relational models means I have one table and then I have another table, and then there is a relational with the database such as the primary key or the foreign key, and so on. We can also deal with the different storage, indexing, and etc. And there are also some vendor specific on this area. For example, the ESRI. So this is a name of software. They use the ArcGIS. Maybe if you want to check, ESRI. So it is a company, the Geographic Information System company. So they have their own data structure. They use the ArcGIS. Or you can have the map info. Yeah, this is the map info. This is another company. So they have their own way to specify the spatial data. There is another company, Intergraph. Intergraph. So it is the GIS company. This is not the GIS. I think this, yeah, Intergraph. This is the GIS company. And yeah, you can have many other companies, and every company they have their own structure to deal with this spatial data. And of course, when you deal with very big data, you can make the data cube. So if you still remember the data cube, it is the multidimensional. Yeah. So usually the data cube consists of at least 3 kind of dimension. Yeah. Both dimension and measures may contain spatial components. So let's say if we are dealing with the spatial data warehouse, we need to understand what is the dimension and what is the measures. Do you still remember? In the data warehouse, we have the dimension and we have measures. The dimension means we want to check all the attributes from the data. For example, I want to understand the attribute of the non-spatial. The attribute of non-spatial, it can be related to the temperature, for example. The temperature is between 25 until 30 degrees. Okay, it can be generalized to hot. Or if I have some spatial data and I want to make it into a dimension of non-spatial. For example, yeah, I make an example in the Pangyo area. There's one region, they call it as Unjungdong. So we want to put this into a generalized non-spatial description like West Pangyo. So actually, in Pangyo, they have the Saw Pangyo, Dong Pangyo, but it is not specific in the map. Okay. As far as I know, it is split by the Dongbu Gusuturu. Okay. So if it is on the left, it is the Saw Pangyo. If it is on the right, it is the Dong Pangyo. So we can make that kind of spatial data. This area is in the west. It is the non-spatial. Or we can make the spatial to spatial. It means you want to generalize the area. Let's say Bundang is popular, but actually Bundang it can be generalized to the higher concept, which is Gyeonggi. So some measures, if you still remember in the data warehouse, we have some measures like the numerical, such as the distributive, algebraic, and holistics. The distributive means count, sum. So how many population in that area, and then how many times occur raining, how many times it was hot, and etc. The algebraic means the average. The holistics, we know the measures about the median and rank. Or we can also make the measures on the spatial. Spatial measures means the collection of spatial pointers. For example, the pointers to origin with 25 until 30 degrees in July. So these are the measures in the data warehouse. Let's say, yeah, so I took this one from one paper. You have the input, and in Seoul, they call it automatic weather stations. So you can collect all the information about the temperature in Seoul. And then you have the daily data. So you have the daily data for temperature, precipitation, wind, velocity. So you can combine this 23 data with the daily data temperature, usually you know from the weather forecast, KMA. And then you can also use the concept hierarchies for all attributes. For example, you know musen dong and then musen gu. So you can also make that one as the hierarchy. And the output can be the map. So here is the map. Based on the weather, okay, we can see that in the spring, okay, the blue color is lower in the temperature than the yellow. Okay, so the yellow is higher in the temperature, but the blue is lower in the temperature. So you can map like this one. What is the goal? Yeah. We can have some interactive analysis. You can drill down, so you can look, okay, what is the area in the blue? What is the area on the yellow? Okay, and there are some areas here also in the blue. And then, yeah, whenever you have this kind of pattern analysis, you can make some fast response time, and it minimizes the storage space use because you just map like this one. But the challenge is a merged region may contain hundreds of primitive regions. For example, we call it polygons. So now it is not clear about the polygon, but in some area, it is not directly like rectangle like this one. Some area might be with this kind of shape. So this kind of polygon is a challenge. So when you have the data warehouse, you can have the spatial data warehouse. For example, this one is from the Seoul data. We can determine what is the region name, and then the region name in a particular time, what is the temperature and what is the precipitation, and what is the measurement. If you still remember the fact table, this is the fact table, this is the Seoul weather. So the region name, we can specify in the dimension table, the region name dimension. We have the prop location, the district, the city or the region or province. The time dimension, we can have the dimension table, time, day, month, season, sorry, typo here. Temperature, the temperature, you can make some kind of information like the temperature or the temperature range or the temperature description. So you can have like cold, cool, hot, warm, and etc. Or the precipitation, you can make also the dimension table of the precipitation. What is the current precipitation value? What is the range? And some description, whether it is humid, non-humid, and etc. The measurement, is about the region map. So how many regions there are in the particular precipitation or in the particular temperature? What is the area, and count how many areas, and etc. So this is an example of the star schema in the data warehouse. When we deal with the multimedia data, we can make the multimedia based on the description. So if you learn about this kind of multimedia, many jobs during the pandemic, they have the data annotator or data annotation. What does it mean? When we see this kind of picture, Yeah, we know that this is tiger, but the computer didn't know that it is tiger. So we need to make description, or we need to make some annotation. We call it the annotation or annotator. Annotator is the person. So whenever we have picture and we make description, so we can build the index, and then we can perform the object retrieval based on the image description. So if you take picture using your smartphone, you can see some captions, or you can see the size of the picture. You can see also the time of the creation of that picture. Okay. Or maybe you will use some keywords. Let's say if you download a picture from KakaoTalk, then you will see the description. The file has been downloaded from KakaoTalk. Okay. They have the word KakaoTalk. So if you need to make description one by one, it is labor intensive. So if you perform manually, of course, it is very time consuming. So that's why I think a few months ago, a few years ago, this job is very popular because it is impossible to make the automatic annotation. Human should involve. But the results are typically of poor quality if automated. So yeah, it's very difficult to make it automatic. This is for the retrieval system, because in the multimedia, yeah, we need to make some label. There's another way to find the multimedia. We can find the similarity of the multimedia using the content. What is the content? The content means we want to see the color. Let's say, yeah, this is bus. I think in UK, most bus are in the red color. So if I know that the dominant is red, then it is bus. Or we can see from the texture. Okay, the texture here is rectangle, rectangle, rectangle. Okay, then it is a bus. Here, oh sorry, the texture is the detail. Like this one, we have the texture of the dog. Objects. So we know that maybe those figures may have similar objects. Okay, we can see the airplane, aeroplane, aeroplane, aeroplane. We can see maybe this is the helicopter. So maybe they are in the same content. We can apply some wavelength transform. If you still remember, in the beginning of our class, we learned about the wavelength transform. So if we have this kind of content, we call this is the content-based retrieval system. And usually when we do with the content-based retrieval system, we can distinguish the color. So the color can be distinguished into RGB. R means red, G means green, and B means blue. So how many of red? There will be a number between 0 until 255. And the green color also, there is a number between 0 until 255. And also the blue, there will be a number between 0 until 255. So this is the basic RGB histogram. When you have this kind of histogram, then it can be distinguishing the picture. For example, like this one, the blue color is dominant, but the red and the green is low. For this one, maybe the green color is dominant. So this is what we call as the content base. When we are dealing with the query means we want to search into the database. And if we want to query the content-based image, we call it the content-based readable system. There are two kind of queries. We can use sample, or we can use the feature specification. What does it mean by sample? So we can find all the images that are similar to the given image sample. So for example, I have this picture. So I have this sample. So I will extract the feature, and then we can query based on the image features. So the image features, one of the image features can be the RGB features. So the features can be this one of the features. So if we look at the data, okay, after we extract the features, then we can query the image features, and we can compare the feature factor extracted from the sample with the feature factors of images that have already been extracted and indexed in the image database. So we have the image database. We have the query image. So we want to extract the feature as well. So we have the feature database. And we can compare this one, or we can make the similarity. If we want to query based on the sample, we will do something like this one. If we want to query based on the feature, what is the feature? The feature, it can be related to the color. So I want to know all the pictures who have blue. Then it's based on the color. I want to know that the picture contains any line, texture, or I want to know the picture that has rectangle or shape. So it can be translated into the feature factor. So match the feature factor with the feature factors of the images in the database. So again, we can have the query image features and then matching with the database. So if with the feature specification, usually we don't have the query image, we just have the feature. So we have only the feature, and then we do the similarity matching with the feature database. When we have the image, we can make the signature. What is the meaning by signature? Usually the image can be denoted as the color histogram based signature. So people know that this is sunset. Why? Because the composition of the color, it contains of yellow. This is the very highlighted yellow, and this is black. Maybe it is because of the sunshine. So we can make the color histogram. If you know the histogram. Histogram means the distribution of the data. So this is the example of the histogram. In this case, we know that the yellow color is dominant. Yellow and orange is dominant. And maybe this one is like dark yellow. So if the color histogram shows like this one, then I can say that this image is related with content. So there is no information about the shape, there is no information about location, and there is no information about texture. We just use the color. Two images with similar color composition may contain very different shapes or texture, and thus could be completely unrelated in semantics. So whenever we use this color, because we just use the color, sometimes we cannot indicate because there is no shape, there is no texture. So it is limited. But yeah, in the previous days, this is the common approach to find the color histogram. And there can be also another approach to see the image signature. For example, this is, we call it as the multi-feature composed signature. So it is not only based on the color, we call it the multiple features because we combine all the features. We consider the color, we consider the shape, we consider the location, and we consider the texture. So usually this is done in the health. So this is the pathological image generation. This is to indicate the tumor. So if it is about the health, then it should have the combination of all the features. If we look at this part, okay, this might be the dangerous part. Then you need to find the texture. The texture of every of this figure, it can represent some disease. And also the color. Okay. The color can represent some of the disease. And if you already know, okay, this is the carcinoma, or this is the carcinoma in situ. This is, they call it as dysplasia, or this is normal. Then yeah, you can store this database, or you can store this label into the image database. And whenever you try to test new figure, then you can do with the model. So you can test this data and check in the model. It can be used to search for similar images. If it is high similarity, then yeah, it can be the tumor. Or maybe if it is highly similarity to the normal, then it is normal. So in the kind of image, usually we have the color histogram. Okay. We have the texture. We call it morphology, and we also have the topology. So there are many kind of features in order to understand the image. So there's a kind of library. In the previous days, they have the CBERT. CBERT means the content-based image retrieval from digital libraries. So we can have these figures, and then from this figure, this library will extract the relevant features. So they make the color percentage, they figure out the color layout, they figure out the texture density, they figure out the texture layout, they consider the object model, other things like illumination invariance, and keywords. So they extract this one. So if you want to search the image by using this value, yeah, you can easily find the figures. Because this is the SIBA. It was generated in the Netscape. It is very long history web browser. Okay. So there's this kind of multidimensional search in the multimedia database. Yeah, they use the content-based search. Let's say I have this figure. This is a dolphin, and the width is 640, and the height is 482. It means the width, we have 640 pixel, or we have 640 rectangle, and here we have 482 pixel. So if you want to understand this pixel, we can make it a lower number. Let's say 8 multiplied by 8. It means the width is 8 and the height is 8. So we have like 1, 2, 3, 4, 5, 6, 7, 8. There are 8 boxes. And for every boxes, it represents with the dominant color. Okay. So this box has dominant, maybe, yeah, if you can make like this one, this is 1, 2, 3, 4, 5, 6, 7, 8. So from 640, they compress into 8 multiplied by 8. And they just show the dominant color here. You can make also 4 multiplied by 4. So like this one, 1, 2, 3, 4. So we can see the dominant color is the blue. In this case, there are 3 dominant colors. In this case, there are 2 dominant colors. In this case, we have 1 dominant color. Or if you want to make it 2 multiplied by 2, then it is smaller again. So we have 1, 2, 1, 2. Or if you want to make 1 multiplied by 1, so it is only 1. So the dominant color here is the blue, light blue, and black. So because this is the color layout, if you want to see from the pixel base. And we can also measure the percentage. How many percent of the blue? How many percent of the black? How many percent of the light blue? And how many percent of the cyan? This is the color of cyan. So this is the color histogram. We can also see from the texture layout. So if it is 8 multiplied by 8, then we have 1, 2, 3, 4, 5, 6, 7, 8. So from the picture, from this picture, we want to find the texture, and we want to find the dominant texture in 8 multiplied by 8 pixels. This is 4 multiplied by 4, this is 2 multiplied by 2, this is 1 multiplied by 1. So the dominant is the horizontal line, like this. So when we deal with the multimedia database, there are many ways, okay, to search the image. Okay. So you can refine or combining the search. For example, if I want to search, we call this is the picture, and I want to search based on the text. So I want to search blue sky. Then we can see, okay, the blue sky are this one, this one, this one, this one. Maybe our eyes can see this kind of figure, but we need to make this description, or we need to make this kind of things. The computer should understand this one. So if it is blue sky, then maybe the color histogram, the blue color should be the highest. Or if I want to search for airplane in blue sky, so we need to find only the blue color and the airplane object. And if I want to find, for example, the blue sky and the green meadows, so I have the blue sky, I have the green meadows or the green forest, then this will be the result. So yeah, based on the texture, the color, we can have some kind of mining from the multimedia database. Okay, I think I will stop here. I will continue this feature descriptor with some calculation on Thursday. Okay. Any questions?